Tuesday evening. Just got done having a fun-filled 2 days with my teacher. Come and hang out with me for a couple days and learned a bunch. Play with a bunch of stuff, but also what happened was Memorial Day. I want to take a minute and say, hey, thank you, gentlemen. A large portion of my customers are retired or active servicemen. I want to say thanks for your service first, and second, I want to say thanks for the gentlemen that have given most, and some have given all, in the creation, the protection, and to service of this great country. Oh man. So anyhow, I'm finally back on track. I'm over here working. Now Chad has got this beautiful Sb220, and the tin on it is perfect. Now, Chad sent me this Sb220, I'd have to say almost 3, maybe 4 months ago. Because it's got every little hardbox tool, toy, and upgrade in it that you can get, except for the soft start and the soft key, which I'm not a big fan of the soft start in this particular box. The circuit that they sell is very weak, and I think it's a waste of money. I think that's just kind of a bragging thing for this particular amp and the way it works. The capacitor bank really isn't big enough to worry about having that inrush short. They try to overcome it by putting diodes on there, but anyhow, he got this from a local gentleman of his that had it sitting in a closet. And of course, the common thing that happens with these little Sb220s is when they sit for a long period of time, the caps dry out. So of course, it's got the hardbox electrolytic bank in it, and the hardbox board in it, and rectifier board in it. But he did go through. He'd been watching some of my videos, and he grounded his own grids. And like when I talked to him on the phone, I said, bro, give you an A for effort and a D for solder work. We both laughed. Where he grounded here and where he grounded here, it looked like, well, chicken poo. It's okay, I was making connections, but so we went ahead and we cleaned all that up for you. I went ahead and cleaned your relay contacts for you while I was here, Chad, so you don't ever have to worry about dealing with that ever again. And then the fun started. So I'm going to pause this thing real quick, set the camera down, and set the amp down, and we'll start talking about that. So give me just a second. Okay. So we got her set back down again. He's sitting there talking on it. He told me he got this from a local gentleman, and they'd all had different hardbox upgrades, and he kept burning out a parasitic. He said it was on the left tube. And so he got on eBay or off the hardbox page, and he ordered upgraded parasitics. That's one way of installing them, my friend. This is the way that you had them in there, so that's the way I'm going to leave them. I redid the solder work here. The connection was pretty, but we went ahead and redid that. There's a couple ways to do these. You don't want to set them up so that the horseshoe loops are in the same phase angle with each other, or they'll oscillate. But this does work better than the wrapped parasitic choking for this particular amp. He said he's talking on it. He goes, man, I don't know what happened. He goes, there's a bunch of high volt, or smoke started coming out of it. I seen it was in the high volt section. He goes, man, I'm just done. Done even trying to dig it with it, so I'm just going to send it to you. So Chad is also a ham guy. He's not a C-beer. Now, it's okay. We're not going to judge. See, around here, my house, C-beers rule king, and the ham guys that look down on us, C-beers that all got their start in the ham radio world, in the CB, I kind of look back at them and laugh. We're all part of the same team, you guys. Just some of us don't have as much bandwidth as the others. Now, I'm a ham. Got my ticket when I was 12. So I'm one of the team. I just play with everything. All that aside, we're not going to hold that over Chad. We're not going to pick on nobody. We're not going to make no jokes. We got her all figured out for you, man. She's running top shape. We're going to start out on 80 meters today. But we're going to start out low. We're going to go through all the bands. Now, when I first opened up the cabinet, I noticed this. This is the second choke for the plate circuit, which sits here. It had burned up. Now, in certain angles of operation, that can act like a fuse because it's the weakest link in the high volt section, if you think about it. This wire is slightly bigger than that wire is bigger than this wire, and if there's a short anywhere in the circuit on this side of the deck, which is usually either from a shorted tube or from somebody popping the lid and the high voltage disconnect, which is right here, being shorted, it can burn. But if that disconnect is shorted, this portion of the circuit is safe and it backs up and blows up the diodes. He did have one popped high voltage diode, which is the second one in here, and I replaced it, and it is fixed. None of his meters were working properly, which told me that there had been a catastrophic high volt short. And on the back side of the meters, especially the plate ampere meter, there's two counter-facing diodes that sit back in there. And when one of the diodes pops, it cuts the amount of display current by a full 2/3. So when I keyed it, and the first time after I figured out what was wrong in the high volt deck that was causing a short, it came up short, and I went, okay, I know what that is. So we got that fixed. The protection for this is fixed. We pulled the capacitor bank out, pulled the high volt board out, redid that. I cleaned all your switches down here, your grid, your relative power, your high voltage, and sensitivity. Also cleaned the on-off switch. I dismounted this and I took it apart, cleaned the contacts, and re-greased it. This is one of the weakest links in this box because all the current goes through this switch. And I'm sorry, after 30 or 40 years, I mean, let's face it, the parts that are in this thing that aren't Harbach upgrades, well, they probably were produced around World War II, I mean, the tubes and so forth. So we cleaned up this switch, made it right. I reset all of your knobs so none of them are dragging on the face because this face is mint. It doesn't have cigarette stain on it. It's relatively clean. There's a couple little chips in the paint from sliding the armor on and off. Overall, this thing is in really, really good shape. Also, I went through and I re-indexed all the knobs on the front of this thing so they all point at the appropriate places. So like if you're going to go work for 15 meters, turn this knob, you're going to be at 15 meters. You're going to turn it to about, let's see, 15 meters, you're going to load it about that far. And it's actually going to load out in that neck of the woods. And it's all modes is the same thing. I took myself some notes on where to tune this puppy. And like I said, we're going to start out at 80 meters. So that's 3.1. 3.1. Move to the 80 meter band. And as we know, the lower you go, the more capacitance you got to add to the tune load circuit to make it work. The other thing is I found this little 25 watt, 25 ohm resistor. And it was over here. It was tied in line sitting just like this with electrical tape around the leads. I give you an A for the electrical tape, bro. I really do. The problem is electrical tape is only good to 600 volts. So there's only 600 volts of protection here. You get one layer. This vinyl tape. Let me get this out of there. And I dug the tape out of there. That would have bugged me. I couldn't have let that go back with that. This is like a secondary glitch resistor. Now they've already got this built into the amp. They've got it on the ground side of the circuit right here. And for this meter to read properly, you can't have any separated resistance lift above ground because it's already on this board. I can already hear guys out there that think they know a lot more than what I know, but that's okay. Take it on the chin. This is a good form of protection. The way we use this kind of resistor, a low wattage or a low resistance, high wattage resistor, this acts like a shock absorber. So if there's a short in the high volt side, on the B positive side, the short backs up, protects the diodes, and acts as a shock absorber, okay? So when the short comes present, instead of it fully crushing down and crushing the bridge inside the diode, the load backs up inside of here and causes another part to fail. The problem is if you're going to put it here on the capacitor bank, it's not protecting anything other than the capacitor bank. So this is an effort, just in the wrong placement. If you're going to have a glitch resistor like this, you're going to put it here on the B plus side between the amp deck and your rectifier board, which then allows you to have a nice level of insulation. If there's a short inside the deck, it's going to back up inside this resistor and not wipe out your diodes. There's really no realistic place to mount this. I'm going to send this back. Chad, if you want to put this in here, brother, that's your call. It's going to go between here on the wire and this post. Just saying. It's there. It's not needed. But it's there. It's a great idea. I mean, it's a great idea. If you wanted to fully isolate your bridge network from having any kind of problems, you'd put, let's say like a 10 ohm, maybe 30 or 40 watt resistor And this only works for 3500Zs. If you're going to go bigger in tubes, like a 3000 or 10,000 or 15, you'd need a higher watt resistor, like 100 watt or 200 watt. You put it on the B plus side between your amp deck, and then you'd put it on your ground return post off of your rectifier going to ground. So it'll lift everything just a hair above ground, but that one little volt of difference is not going to make any difference in performance. It's going to keep you from having to rebuild your high volt board if you're having problems inside your amp deck. Chad was having problems inside of his amp deck. Let's get on to that for a second. Hold on 1 minute, I'll be right back. Got my shop dog out here with me. The Mowgli. You were chewing on your foot, weren't you, buddy? It's okay. He's over there gnawing on his foot, and I had to go see what the deal was. So I get all this fixed. I go through it and check it all with it. And it's time to start applying power to it. Because to pull the thing out of the box and plug it in the wall and turn it on is just silly. You're going to end up blowing up more parts than you need. So I always start by checking everything first. Those are the problems I found before I turned the power on. I still hadn't found the short. I mean, when I first took it out of the box, I was instantly underneath the assumption that he'd had a shorted tube. Called him, had him do the spin test on the tube to listen to hear to see if the filament was clanking around. He had one bad tube that had gassed out on and shorted out on him in the past. Yes, that tube, the little clank test, and the tube where you hold the tube to your ear and you slowly rotate it. You get your ear going ting, ting, ting. It's bad. Had him go through all of that. Neither one of his tubes were that. So I'm like, okay, I can only find it if I start putting power on it. So I rewired it for 110, put it on my Variac, and started cranking up the current. And then the weirdest thing happened. This doorknob started smoking. So I pull the current back, bleed everything off, short everything out. I take the whole capacitor bank out, because there's a screw that's behind this capacitor bank, behind a piece of insulation foam, or not foam, but insulation tape, behind a piece of old resin, probably asbestos-based board that's in here. It's that old. There's a screw that holds this doorknob in. I undid this screw. Normally you can get the doorknob to spin. It wasn't having it. And then I discovered why once I got it dug out of there. Chad, here's your two old blocking doorknobs. Now, when I see these come up for eBay, on eBay, electrolytics, the band switches, the whole load and tune sections, I usually buy them. I've got a lot of these here. I've got 5 of these Sb220s here. I got 4 of them that are waiting for parts. One of them I was able to fix in-house. Most of them, 2 of them have got capacitor bank issues. The other one's got band switch issues that I've got to go and take band switches out, which is a long process. So I figured out what's wrong with them. Get parts coming. Anyhow, these are your old doorknobs. You guys ready for this? This is the one that was on top, Chad, and it was indexed this direction. And you can see the burn mark from where it was starting to back up. The problem was the journal the screw goes into on the back side of the cabinet is spinning. This thing has got the consistency and the texture to it of like a super bouncy super ball, like a little rubber ball you give a kid that he'd smack on the driveway and it takes off like 40 feet in the air. Not only this one, but that one too. Now these are supposed to be harder than a coffin nail, harder than the back side of my head, like this. Can't mend it. What happens over time, and you got to remember this is probably a 30 or 40-year-old amp at this point, sitting in some guy's closet. Over time, moisture has leaked itself down inside these caps. This one is a dead short. Short to ground. This is where your problem was at. And I bet you've been fighting this problem on and off. It's been presenting itself in parasitic issues, in rectifier issues, capacitor issues. Probably most of your problem was actually right here the entire time. This is an intermittent short caused by moisture. Moisture can leak into the casings of these and completely ruin their value. This is a dead short. This one, on the other hand, it charges up like it's an electrolytic. So you put it on a capacitance checker and it just slowly walks up like it's a battery. Now, Chad, I'm going to send these back with you. You can put them on your wall. I replaced them with 2 snuff, not moisture contaminated caps that I want to say are new, but they're used old stock, but they're up to snuff and they work fine. Chad, I got my 2 tubes in there. We talked about your maximum amount of drive on this thing's going to be about 230 watts. You said your radio that you have only does about 100 watts. So I had to go borrow one of my wife's radios. I got like 3 of these laying around here, and this one supposedly was going to go on my wife's truck for when she got her ticket. She got her ticket and just never got around to installing it. So I borrowed this thing so I could throw it up on the workbench. We're going to use a 100 watt slug going forward to show input drive and the amount of wattage coming out of the radio for each one of the bands. Use a 1000 watt slug in 2X and PEP, 1000 watt slug in forward and average, and a 5 watt slug in reverse back from the bird, 10,000 watt numbing load. Everything that we're going to do here today is on a sealed, closed ground system. I've done everything with my due diligence and possible effort to keep any bleed RF from being actually transmitted into the atmosphere. So that means we can transmit at any frequency we want in any modes of operation we want, because it's closed looped and this is for research. So therefore, there you go. Because as I screw through the bands, I'm sure I'm going to miss and not be like directly within the band path that ham radio operators are allowed to use. I'm not going to identify myself, and I don't want to end up having to deal with people flipping out about it. So there we go. Okay. Got legal covered what was going on with it. What do you say we do some testing? Okay, I'm going to get this thing fired up. We're going to get her dialed in on the money, and we're going to go from there. Be right back. I was reading a study the other night about distance and high voltage's ability to conduct itself based upon the atmosphere, altitude, and moisture content, and the actual molecules that are in the atmosphere. It's generally assumed that 1 inch is good for like 20,000 kV, 20,000 volts. You guys, you watch me move around these things a lot. I don't want to say I'm comfortable of high voltage. I'm terrified of it. But I have become very comfortable working with it. One of my previous career paths that I had when I was a younger, dumber, full of piss and vinegar, my hair's on fire, and I'm going to go show the world how big and bad I was as a power lineman. Working with 100 and like 14.7 was nothing. That's just the wire going down the road that feeds the houses at like 14.7. That's 14,700 volts. I've hot gloved on 28K, and then above that, I've done hot work off helicopters and all kinds of stuff on a 450 kVA and 500 kVA lines, 150 kVA. I'm terrified of it because it's bang, now you're dead. If I die, trust me, I will not be around to tell you about it because I'll be dead before I hit the floor. The camera doesn't show depth, and I get people that tell me all the time, you got to be careful working around high voltage, it can kill you. Oh God, no, I know. I've been through every OSHA class that you could ever be sat through for high voltage, I know. So with the 3,000 volts, 3,100, 3,200 volts that are on the plate on this thing, I'm not absolutely deathly afraid of it. I have an insane amount of respect for it. Please, if you don't know what you're doing, keep your hands out of the amp. And never, ever, ever use a screwdriver to touch anything. So it looks like I'm touching something, right? No, I'm not. Screwdriver is really about 6-8 inches away from even coming close to the amplifier. See? The video can fib to you. Please don't ever use a screwdriver to reset a tube in a socket. Completely ground the amp, unplug it, make sure it's shorted out. And while working in that compartment, make sure it is shorted out. See right there? I'm still 2 feet away from the box. Please be careful with high voltage. The numbers of guys that we've lost this year have gone way down. I think that has something to do with the radio community starting to thin out quite a bit. Mother Nature, the skip conditions have changed quite a bit, and they're falling out, and guys aren't trying to get every last stinking watt out of the box. Please don't do any silly, like stick screwdrivers inside the amp deck. Please always operate the amp deck with the amp deck closed up, sealed off, and grounded, whatever you're using. I'm the one sitting here taking all the radiation in the face that's coming off the tubes. I'm the one taking all the RF energy to the eyeballs. I'm the one taking the risk with the high voltage. Please respect what I have to say and let me do it for you. I've I've had hundreds and hundreds and thousands of hours, literally thousands of hours. My apprenticeship program was 4,000 hours long when I was a power lineman. Please leave the high voltage up to us professionals. Keep your fingers out of that space. Okay. Now what we're doing right now is we're just going to give you a general reference. Performance can vary depending on the quality of the tubes. Those are 2 brand new Taylors that I use in all of my test videos. If like you ever sent me this amplifier, I tell you on the phone, don't send me the tubes, don't need them, I got my own. Okay, got all the legal out of the way, got all the responsibilities out of the way. We're going to start out up on 80 meters, or down on 80 meters. I hate when people say up, it's down on 80 meters. Please note where the knobs are all indicated. So we're going to step on a pedal. And at 0 signal, we're hovering just above Class C in a Class B configuration at the moment with the amount of grid current that's being pulled with this particular tube. Now, before we go, when we stand on that, that's a 100-watt slug in PEP in a forward position. That's a 230 megahertz slug. And the same is going to go rest for all the other information on all the other slugs that we're going to look at. We're not going to change anything. Like I said, that's 2x, one in the middle is 1x, an average 5-watt slug in reverse. So 100-watt slug in 2x position, or 1x position, pardon me. So we're going to dead key 40 watts. We're going to swing about 110 from the wife's ICOM into this radio. We're not going to mess around with the CW tune portion. I'm going to take care of that between each steps in this video. We're just going to do it in the sideband position, which is, well, the higher voltage. We are going to operate an AM throughout this entire video. I'm not interested in trying to show a whole lot of swing and make the needle move. I'm trying to show what the amplifier is capable of doing. I want to demonstrate a high actual RF dead key, because therefore all the components inside this box are going to work at their most electronic physical strain that they can possibly operate underneath of. And if it doesn't fail here, that means when it gets on the other end of the customer, he's going to have success. Step on the pedal, 40-watt dead key. 40-watt dead key gets you 500 dead key coming out. So we're achieving our 10-to-1 gain. And we're still pulling less than half amp. Hello audio. Hello audio. And we're getting 16, 17, some change out of it. Peak power. Bird average. Hello audio. Doing about 700. Okay. All right. 80 meters, working. Working. By the way, I've got an amp I'm getting ready to come out. It's from my buddy Popeye. He's been waiting a couple months for me to do this. He's got an Sb220. He's a mono bander, and he keeps having this tuner arc. Now, they sell this aftermarket tuner. That is the aftermarket tuner that drops in there and replaces. I'm going to show you even a better mod where we put a vacuum variable in there. If you have an air tuner in there and that thing gets dust on it or gets dirt, or you live in a high moisture environment, you can have an arc on this tuner. I'm going to show everybody how to do it with a little vacuum tuner, and then you never have any more problems. The downside to that is there's so much screwing on the front. For a multi-band amp, it makes it a little bit complicated. Guys that run just like one frequency, like 80 meters or 40 or 20, or even the guys that work on 10, put a vacuum tuner in it. It'll quit screeching on you. Okay, we're going to reload this sucker for 40, and we're going to get on with the show. Okay. Once again, we're in a full high put output section of sideband. Put 3100 on it. We are going to run into this thing. 40-watt dead key. Hello. And we're sitting up here on 40 meters. All right, 40 meters. All indexed the same place. Yeah. Step on our pedal. We're going to get our 500-watt dead key again. 410-watt dead key. We're 40 watts going in, maintaining our 10-to-1. Hello. Hello. Now I'm shooting this in high def. Hopefully that caught that thing. I don't like taking my arm across the top of that cabinet and keying the microphone and stepping on the pedal. Too many cross paths of possible chance of having something go back to me. This thing is doing just short of 1800 with 130 watts of drive on the input at the high volt setting. Perfect. This translation. Also, when I had the faceplate off, Chad, I went ahead and I tuned all the different bands. with an actual bird meter in between the radio and the amplifier, and tuned everything to where it says very, very, very little reflect. Okay, let's move on to 20 meters. Okay, we're all loaded out again for 20 meters. Pretty straightforward. Radio's on 20 meters. Once again, let's key it. Still got our 40 watt dead key. Swinging at probably 120, 130 watts. Let's go and step on our pedal. Still below our half amp. Now get dead key in a little bit more. We're still achieving our 16 to 1700 watts out, and we're getting our 650 to 720 watts bird average. All right, let's continue on to 15 meters. All right, so we're loaded out for 15 meters. Right inside the band plot for that. These things get really touchy as you go up and get closer to the 10 meter portion of operation for these. The tuners, as you're loading it out, you're going back and forth, back and forth, back and forth. Meanwhile, loading out your radio and looking at your watt meter, and you're going back and forth, back and forth, back and forth. I'm telling you, it's like... It gets really tight, and it's because of this tuner. This one here. The tuner is really... It works. I'll put it to you like that. It works. It's not really the thing that was designed to be in here. They designed it to use the tuner that's in there that everybody hates because it arcs over when you get in upper in the bands. It works. It just gets really touchy. So you can achieve great deals of wattage, but then you breathe on it wrong, and the knobs move just enough to fall it out of resonance. It gets really tight. And what we're doing is you're going higher in frequency. You're uncoupling the capacitance out of the circuit. So the circuit becomes more and more resonant. The higher you go in frequency, it needs less and less capacitance, and it needs less and less inductance to get to the 50 ohm resonant point to match to the tube network. When this, as you can look down there and see, starts to unload itself, the capacitance in the tuner starts to get a little flaky. That's why you got to be so soft with it. All right, we step on a pedal. Same thing as before. 100 watt dead key going off the chart. Key in. Still underneath our half amp. 3000 volts in the plate. Hello audio. Hello audio. Same results as all the other bands. Now as we start going up, you'll see that the power started to fell off. We've lost about 150 watts of peak power and about 30 or 40 watts of average with the same amount of drive. That's the shortcoming in the tuning section for this box. When we get up into 10 meters, it's going to fall off a little bit more. I think they were trying to nerf it for the CB guys, but the CB guys just ram the crap into the... I mean, they just drive the holy shit out of these anyhow, and it overcomes it. But for a 120 watt peak radio and maybe 50, 60 watt average radio, I mean, you can put up to 220, 230 watts of peak power into these things, and you get an increased in performance. But let's go ahead and we're going to run it on up to the 10 meter band, and then we're going to be done. Finally done, bud. Here's your 10 meter position. Step on the pedal. Right in resonance. We're going to show our drive. Hello audio. Same amount of drive. Step on the pedal. Get our dead key going. Hello audio. Hello audio. That's it, man. She's fully functional, brother. I'm going to shut it down. I'm going to let it cool off. I'm going to pull the tubes out of it. I'm going to go ahead and put all the tins and everything back up. We're going to button it up. We're going to send it back to you. All the other thing is add a little bit of oil to the fan. Make sure that thing's not going to rattle on you. This is as best as I know how to make it for you, bud. This is as close back to stock as it can be. It's tuned out for 10 meters and not 11 like it was. It's straight, man. And if you ever want to tune that out again, that one right there is what you adjust. You're going to screw it in, and it'll drop down for 11 meters. Right now it's tuned out for 10, and you're straight. Chad, I appreciate your patience. I truly hope that the wait was worth it for you. I want to thank you for sending it up and giving me the opportunity to work on it. These things are really tough to get shipped up here, man. If you go and you ship any of these things, the guys are watching this video. If you're going to ever go and send these things, please take them someplace, have them professionally packed. Don't try and pack them yourself. Don't send them with the tubes. Make sure you send me the information taped to the top of the cabinet. Name, phone number, address, all your contact information. That way I know how to get a hold of you. But please, really, go get them professionally packed. Insist for double boxing. I've had 3 or 4 of these that have showed up here just in this last year, to when they get here, they're completely demolished. Because guys try to pack them themselves. They don't do enough packing. These things are heavy and they damage really, really easy. And the parts are almost impossible to come by. So, anyhow, gentlemen, my name is BBI. And without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. And remember, I'm not here without all of you. And I appreciate your all's support. I've got a ton of projects going on. A new build box, we're now out to about a year. I mean, come on, I came out with an amplifier you can't break. It's got unlimited key down time. Don't have to worry about the heat, and you can take your antenna tuner and throw it in the garbage because you no longer need it. It's kind of scary. 2 LD MOS units do more than this with a fraction of the drive. Just saying. Gentlemen, enjoy yourselves, enjoy your time, enjoy what we got left on this earth with each other. Be nice to each other. Keep your dick in a vise, and we'll see you. Bye. Sb220. Another guy, 10 8 Street. I'll see you. Bye-bye.